Hello and welcome to the Chapter 16 notes on scatter graphs and time series. Scatter graphs are used to compare two sets of data. We've got an example here of the age of cars versus how much they would cost to buy at that age. I think we'd normally expect older cars to cost less, but let's just see. So we've got our first point here, 4-year-old, £6,000. If we draw a point there, we've got the start of our scatter graph. We've got one that's 7 years and 3,000. So we'll draw a point there as well. If we do all of that, we end up with a nice series of points which seem to be trending downwards. In general, we can see here, the older the car is, the less it costs. Now the language that we use here is obviously important. In GCSE, they refer to these patterns, these trends, as correlations and relationships. Correlation is just basically saying which way is the data going. We can see on our first graph the data is going downwards. This is a negative correlation. On our second graph here, the line is going upwards. This is a positive correlation. On our third graph here, the data is all over the place. Who knows what's going on there? There is no correlation. Relationship is just taking that a little bit further and actually putting that into a sentence. So on our first graph, math scores, when they're high, tend to be low art scores. We'll say that the better your math score, the worse your art score. Whereas on the second graph, the longer someone's hand is, the taller they tend to be. So we would say that the longer your hand, the taller you are. On the third one, we can't say anything useful. We can say there's no relationship between weight and TV watched. Now those general lines I've been drawing, they are also part of the language of scatter graphs. We call those lines of best fit, and definition is on the screen there. Has to be following the trend of the data roughly in the middle of the points. I've drawn on the line of best fit here for time spent revising versus test score, and it says that we want to use this to predict the test score after 6 hours of revision. So what we do is we go to 6 hours of revision, we draw a line up from there, we go to the line of best fit that we've drawn, we draw a line across from there, and we read off the test score that that seems to claim. In this case, I might claim that that person scores maybe 65% after 6 hours of revision. Now there are a couple of scenarios where a line of best fit is not reliable. There are two things that I can point out here, because if we look at our line of best fit here, if we're trying to make a prediction for someone who scored 100% in the art exam, the first problem is that, well, if we carry that data line onwards, and then we make a prediction based on 100 art across to a math score, we predicted them like minus 10% as a score, and you can't really do that. The second problem is that the data itself starts at an art score of about 10 and ends at an art score of about 78. There is nothing outside that range, so we don't know what happens over here. The data probably flattens out, or it might go back up, or it might spring backwards, who knows. This idea of making predictions beyond the range is called extrapolation, and we don't want to do that. So the last and probably most straightforward graph that we need to look at in chapter 16 is time series graph. This is just similar to a scatter graph. We want to compare two bits of data. In this case, we've got Monday, 14 degrees, so we'll make a mark, Monday, 14 degrees, and then we'll carry on, so 16, and then 15, and then 10, and then 9. But instead of drawing a line of best fit, we just join it dot to dot. We can do the same thing for Plymouth, 17, 18, 13, 12, and 10, and then we can try and make some sort of comparisons. So our first question here is, when is the biggest difference in temperatures? And we could say, well, it's Monday, 3 degrees, because we can look at the table, or we can see where the graphs are the furthest apart, and in both cases that's Monday. Second question, which city is warmer and why? Well, it looks like Plymouth, and there's a lot of different ways you could argue it. You could find an average for the whole day, but I would say the easiest explanation would be that it's hotter on 4 days out of the 5. The line is above the Belfast line 4 times out of 5. And a lot of the things that you might want to do with a scatter graph, you can do with a time series graph, namely make predictions. We've got the price of a cup of coffee over time here, estimate the cost in 1995. So we'll go up from 1995 to the line, we'll go across and we'll say, in those days it was £2. Then secondly, we've got Fred predicts the coffee will cost £3.60 in 2020. Do we agree? Well, we could just extend the line, following the trend that we think, and according to that, it feels like it's going to cost more like £4. But as long as you create a convincing argument, then it doesn't really matter how you phrase that.